And if we let that radius sort of just be 1 for right now, and we make an altitude and we draw a right triangle here, then this point over here represents the point x, comma, y, and then this is my point theta. So nothing exciting or terribly crazy right now. Does everyone remember this stuff so far, this setup, this trig setup? Trig, good. So if I was going to ask you, so this is length x and this is length y. So if I was going to ask you, what would the sine of theta be? If my radius is 1, what would the sine of theta be in this case? Yeah. Yeah, it would be y divided by 1, right? So sine theta deals with the y component, right? The y variables. If you're in physics, this should be familiar to you. Sine deals with y, cosine deals with x, right? So cosine theta is equal to x over 1, so in this case it's just x. Well, what we're going to do now is we're going to extend that radius out and beyond from 1, and where it can be anything. But the key part to remember is that sine theta always deals with y values, and cosine theta always deals with x values. Okay? So let's do a little experiment. You need your graphing calculator for this part, all right? All right? I'm going to draw an angle of 24 degrees in quadrant 1. Okay? This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. All right? So if I have an angle of 24 degrees, now 24 degrees is not really a nice angle in particular. It's not a 30, 60, 90. It's not a 45 special. It's just a regular old 24-degree angle. And if I'm with quadrant 1, we're going to experiment with the cosine, okay? So if I ask you, what's the cosine of 24 degrees? Well, you're going to take your calculator out. You're going to make sure your calculator is in what mode? Degree, because you're asking for a degree, right? Make sure your calculator is in degree mode, and you're going to ask the calculator for, hey, what is, turn the calculators on. Some people did not know how to change their calculator to degree mode, so if you hit the mode button, water's back there if you need some. Go to radian, go over to degree, highlight the degree, and that's how you put your calculator in degree mode. Okay, so now hit second quit. So now I'm going to ask, okay, what is the cosine of 24 degrees? And we're going to round to 3 decimal places. So my calculator screen is showing 0.914 if I round up. Is that what you guys got? Okay, let's write that part down. Okay, let me put this here. So the cosine of 24 degrees is 0.914. Okay, just keep that as a reference, all right? Now, let's go over into quadrant 2. How would I draw a angle of 24 degrees but put it into quadrant 2? Well, there's 2 ways I can look at it. The 24 can either be in between the terminal side on the y-axis or the terminal side on the x-axis. And it turns out they'll always be between the terminal side and the x-axis. So here we go. If I put this would be an angle of 24 degrees in quadrant 2. Do you guys agree with that? This angle right here is 24 degrees. All right? So my question to you then is this. If that angle is 24 degrees, what is this angle here? What would that have to be? 180. There's more to it than that. Minus 24. Very good. So this would be 180 degrees all the way around. Take away the 24, which would be how much? 156. Okay, great. Could you please figure out what's the cosine then of 156? So cosine. Okay, I heard someone get real excited over there. What are you guys noticing here? It's just the negative of what it was in quadrant 1. You guys with me on that? Okay, so the cosine of 156 degrees is equal to the negative 0.914. Does anyone have any explanation as to why that might be? What do you think?
The side where like the negative.
You're absolutely right. In quadrant 2, cosine values deal with x, correct? So in quadrant 2, pick a point in quadrant 2. 3. That's not in quadrant 2.
0, negative 3, 3.
Negative 3, 3. Which one's the negative one? The x one, the negative 3. So cosines in quadrant 2 have to be negative, right? Okay, now, let's go to quadrant 3. How could I draw an angle of 24 degrees in quadrant 3? Well, it would look like this. There would be 24 degrees right there.
Couldn't you just continue the y on the first one?
It'd be the 180 plus 24, which would be how much? 204. So let's figure out What's your prediction for the cosine of 204 degrees?
Same thing, negative.
Would it be negative or positive?
Negative.
Because you're still in quadrant 3, and x values are negative there, right? So this should be the negative 0.914. And if you verify that on the calculator, you guys can verify that the cosine of 204 is equal to, there you go, the negative. Okay, so now how do I draw 24 degrees in quadrant 4 then?
Positive 914.
It would be, well, the answer, right? But what would that degree measure be?
That would
It'd be 360 minus 24, which would be what?
236.
336, right? 336. So the cosine of 336 would be, again, 0.914. Okay, so why are we talking about this? Why are we doing all this, right? The reason that we're doing all of this is just to get an idea of where your angles are and the signs that they will be given the quadrant that they are in. Okay, so let's apply this to a situation where you're going to come across like tonight and later on in the week here.
So, Mr. Guru,
Mm-hmm.
if we were doing sine 24, would it all be opposite?
Well, in quadrant 1, everything is positive. Quadrant 2, signs are positive. Quadrant 3, signs are negative. Quadrant 4, signs are negative. Yeah. So it depends on X or Y and which quadrant you're in. And we're going to make a little table later to help you out with that. In fact, let's do that right now. Thank you for bringing that up. So give yourself a giant coordinate plane that looks like this. Okay? Giant coordinate plane looks like that. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is... All right, what we're going to do now is we're going to go around, we're going to label in all the quadrants all 6 of the trig functions and what their sign values are, okay? Quadrant 1 is the easiest and most fun of everything because in quadrant 1, everything you could possibly think of is positive, right? All my sign values are positive in quadrant 1, so anything between 0 and 90 for sine will be positive. It'll be positive for cosine. And since tangent is the ratio of sine over cosine, a positive number divided by a positive number is a positive number. Now, the reciprocal works the same way. If you have a number that's positive, you take its reciprocal, that's also positive. So everything in here is positive. That one's easy. All right, let's go over to quadrant 2. In quadrant 2, the x values are negative. So which one deals with x? Cosine or sine? Cosine does. So cosine has to be negative, which means secant has to be negative. Sine is positive, which means cosecant has to be positive. But what about tangent?
Negative.
Why is it negative? You're right.
Positive over negative.
Because opposite sides are always negative. Right, good. So negative, that makes the cotangent negative. Okay, so cosine quadrant 2, what is it? Positive or negative?
Negative.
Negative. Tangent in quadrant 1. Positive. Cotangent quadrant 2. Negative. So you see how this chart can be helpful when you're trying to figure things out. Quadrant 3, fun things happen. Both sine and cosine are what? Negative numbers, but that makes tangent what? Positive. There you go. All right. And then quadrant 4, my x values are positive, so cosine's positive, and secant is positive. But when I move downward, my sine values are negative, which makes tangent negative and cotangent negative. Okay? Nice little chart to have at your disposal when you're doing some problems and working some things out. So, last idea here is an example. What do you guys think so far? Are you catching on? Okay, so the directions are really long and winded, so I'll read them to you, and then we'll write down the pertinent information. Okay? And so there's find the exact values of all 6 trig functions. Find the exact values for all 6 trig functions of a positive angle theta, so theta is positive. And you know that 4 comma negative 3 is a point on the terminal side of theta. Okay, so that's kind of long and winded. So here we go. Find the exact values of all 6 trig functions of a positive angle theta if you know that 4 comma negative 3 is a point on the terminal side of theta. The best way to get these problems right is to just draw a picture. And that's what we're going to do. We're going to draw a picture in the right spot. So if I know that 4, negative 3 is a point on the terminal side, then that's where it has to be where it ends, right? So that means I need to go 4 over to the right and then down 3. So my angle theta is right here. Since it's a positive angle, it must go counterclockwise, and my theta should be right there. And I know that this is the point over here. This is the point 4, comma negative 3. That's the x value. That's the y value. And then I could always draw a right triangle down here. So our goal is to figure out what's the sine, cosine, tangent, and all that stuff. So I'll set it up. Sine theta is going to be something. Cosine theta is going to be something. And then tangent of theta will be something. And then once I got all those, I have the ones below it. All right, so what quadrant am I in? What do I end up in? I end up in quadrant number 4, all right? So I need a few things here, right? I know the sine of theta is the opposite over the hypotenuse. So what is the hypotenuse, right? If this is a length of 4 and this is negative 3, then this, of course, the r has to be 5, right? And we do that from a special right triangle. So what would the sine of theta have to be then? The sine of theta, yeah, what would it have to be? Doesn't it look strange how it is? What looks strange about it to you? Because it looks strange to me. What looks strange to you? Is anything? Because theta is all the way around, right? Usually, we are used to working with theta right there, aren't we? Now, remember back to the example I gave you up here of the whole 24 thing? It ended up being the same angle, wasn't it? Whether we were dealing with 24 or 156 or 204 or 336, they all gave the same answer except what was the only thing that was different? Positive or negative, depending on what? The quadrant that they're in, right? So this would be the same exact angle. It's actually called a reference angle, but that would be the same exact angle as my theta, so I can call it theta prime, but I'm in quadrant 4. So in quadrant 4, I'm looking at this situation. Sines are negative, cosines are positive, tangents are negative, and so forth all the way down the line. You guys see how that helps you out? Yeah. Okay, so now let's go back here. What would the sine of theta have to be then? You got it, dude. Negative 3/5. What would the cosine of theta have to be? It would be positive 4/5. Yeah. How about tangent of theta? Negative 3/4. So now I have all of these, right? Negative 4/3, positive 5/4, negative 5/3. And sine is negative, cosine is positive, tangent is negative. So you see how this all blends together? They all fit together?
Yes.
All right, you guys. What questions do you have? That's it.